Talking is such a normal part of life for most people, but what about people who can't talk? This is a real situation for people with ALS or even locked-in syndrome who can process the world but had no way to communicate back until recently. Advancements in brain-computer interfaces, specifically using neural decoding, have created a way for these people to communicate, turning brain waves into speech. But how does this work? To start, let's understand how the brain creates thought. Imagine a gated city. This is your brain. At the gate, there are sensory receptors. These could be in your eyes, skin, or more. But then, if a stimulus comes along, it changes the electrical state of the sensory receptor, like turning on a light. This changes what messengers are sent along the road to the neurons, the houses of the city. The house sees the new messenger and triggers an action potential. This is when the neuron opens special gates, allowing charged ions to enter, turning on or off the house's light. This triggers the signal to the next neuron, repeating the process. Patterns that emerge from these repeated neuron activities cause thoughts and different brainwaves. Previously, we were unable to connect what was happening. We could see what was happening in the brain, but were unable to connect it with the speech that was being formed. However, with an improvement in artificial intelligence, neural decoding saw a huge improvement. Now we can take snapshots of what is happening in the brain and train a model to accurately generate the speech that is being produced. This technology has improved so much that patients are able to use the BCIs and neural decoding in order to have live, real-time conversations with others, improving the life of people who were previously unable to communicate with the world.